Morning. There we go. We're just going to do a quick little stream here. Work on a few things. Cryo replay did not work out of the box on neural MMO, no big surprise. But, there's a lot more to fix with this before we draw any conclusions. Yeah, the plan for today is short stream, break for breakfast and exercise, come back, long stream, and hopefully by then this thing will be in a decent shape. We're getting pretty close to the point where I can start running serious experiments on this, I think. Pretty close. Man, this like pre-step, post-step is really annoying. There's just a lot of branching logic in here. A lot of branching logic. Maybe we can fix the maze environment. That is a case where prioritized replay should definitely help, right? Alright. I think this is also a case where I need to leave the Scython in place for now. This has got to be the OBS, right? Actually, we can just do if. We'll just do this. Hopefully we figure out what is wrong with this env. Oh, wrong env. Okay, so this didn't catch it, oddly enough. Maybe this indexing over here is wrong. It's fine, right? No, it's not fine. Okay, how's this happen? OBS is the right size. Oh, it's because E3B is on. Where's this thing? Yeah, this cannot be on because I haven't fixed it yet. Alright, so that train should do something. No reward ever. Interesting. Okay, what about now with this? That's semi-prioritized. Doesn't seem to be getting any score whatsoever. Interesting. Could have sworn that did get some reward before. What about this? Let me make a quick sanity because I'm getting a little suspicious. Oh wait, no, there it is. It actually did get a bit of reward in there. Okay. Do I just need to make this smaller? This should work. Yeah, that works. Okay, yeah, so there's the initial problem right there that we're seeing, which is it getting some reward and then just not doing anything with it. So the idea with the prioritized replay is like, if I take top K, it should never get rid of that data from the train set. Hey, welcome. Currently testing out our prioritized experience replay implementation, seeing how I can improve some things. I mean, this does look like it's doing better at least. It's not just dropped all the way to 0 immediately. But this is not what we'd expect yet. Is this that snake env? Nah, this is like a procedurally generated maze env. The idea with that is it's really sparse. And one of the goals with prioritized replay is if you're in a deterministic env and you get the reward once, then you should basically just keep that sample in your replay buffer for quite a while. And you should latch onto that reward a lot faster. Okay, well this is probably culprit right here. Can I do like 128 on this? Still no, huh? Do you use TD error as priority? Not quite. You use the advantage as the priority signal. I believe JE will give you TD of 1 when you have lambda equals 0. And gamma equal 1 is like baseline discounted return. And then it's this weird exponential interpolation of them otherwise. It's interesting that it keeps getting a bit of reward, but like not quite enough. It's a fixed map in this test. Maybe we just need like crazy BPT horizon for this. That's not gonna fit. Maybe this fits. Maybe this. This will give us weighted random sampling during training, but then it should make sure that we keep samples in the prio buffer. Sum of probabilities less than equals 0. Really? They're all 0. What is this? These are all the right shape. Oh, it's in compute JE. Interesting. There must be like bad data in there or something, right? Steps, horizon. Maybe my GAE is wrong. How does this block IDX get divided up? Hang on. Threads per block. Wait, num steps plus thread per block. 256 blocks. Is that correct? That should give you the row, shouldn't it? Block index, block dim. This should actually give you the correct row. How the heck is this out of bounds? How the heck is this out of bounds? Oh, I guess because it doesn't line up with a block. Is that the issue? I bet that's it. Is that not a multiple of, maybe it's not a multiple, hang on. I think it has to be a multiple of 256. That's an easy check. It's taking forever to compile. Something screwy. This thing got partial compiled, I assume. You built this? And the stats suddenly go down. So I guess then the questions are going to be on the advantage prioritization. Oh, is it training? Hey, look at that. So, that's pretty crazy. Is this 21 size or 31 size? I think this is still 21 size. '21 size. This is solving though, maybe that's not an easy task. We'll see what the actual episode length ends up being. Okay. And we actually will be able to compare now. We'll be able to compare a couple of these. And I think we'll be able to see whether this works the way we want it to. So this is getting lucky a few times from random search. What usually happens is it gets such a small fraction of rewards that when you train on the whole batch, you actually don't latch onto the reward because you get it too infrequently. It looks like, oh, it's very high here, but actually this is just like the first trajectory that finishes is always going to be one where you got lucky. And boom, there you go, it solves. So that's pretty solid. It took longer last time, didn't it? Yeah, 80 mil. So there's going to be some inconsistency as to how long it takes to do that, but still not bad. And now if we go to PufferLib, and we just do method equals random. Does it still solve? This one might still solve, actually, because this is only the 21 by 21s. We will see. Yeah, so this one still solves. I believe 31 is where it starts to get very difficult. Yeah, so this is too easy. You need to be able to at least get some reward in order for either of these methods to work. So we will see whether we get any reward at all. So far, no. So 21 might just be doable and 31 might just be impossible. Yeah, so that's just 0 reward. No method will be able to solve that, at least without, like, explicit exploration stuff. We go sort of somewhere in between. It needs to be something that consistently gets some reward. 25, maybe? Also don't know how this thing is seeded. It got some, I think it got like 1 solve. Okay. There you go. That's a very sparse, small amount of reward right there. So this is what we're going for. This is the, like, if you run it for long enough, you will eventually get a solve. But as you can see, it's not like solving it again at all thereafter. Okay, so this is where we would expect to maybe be able to do something with prioritized replay, though this is like crazy, crazy sparse. I guess if we get the trajectory twice, it should be enough. Okay, so now we do prioritized. Got the little score spike here. Now we do prioritized. Yeah, and if that's consistent, we're good. Right, if that is a consistent result, we are good. It's a crazy sparse task. Okay. Let's just run it again to see if it replicates. Because we don't get the lucky early solve at this one. Oh, there's one. And it does a pretty good job of getting more solves. Good day. Welcome. Okay, so this is a perfect test if it's able to solve based on this. I would think that it should be able to, because as long as it's getting some reward, it's going to run a whole bunch of epochs on those trajectories. It's still a hard problem, mind you. So it's fine if it takes a while. We just want to see if it actually can get something with this. It shouldn't be possible for it to just be permanently stuck here based on the new algorithm. In PPO, without prioritized replay, what can happen is that the reward is so infrequent that you just get drowned out by noise. But here, since you're running so many update epochs on the good samples, we should see this solve. Yeah. Okay, so it seems that those are very good signs of life for prioritized replay. Very, very good signs of life. Running on one map like this is going to be really inconsistent. But solving 31 by 31 mazes without curriculum or anything is kind of crazy. You can see there, this is currently a 800 horizon task with 1 reward. So yeah, I'm taking 91 million steps just to solve a maze, but this was like 800 steps, 1 reward. So that's pretty good. As far as like exploration tasks go, like benchmark exploration tasks, this is ridiculously harder than pretty much anything I've seen in academia, and this works. Cool. Now we do the randomized version of this thing, and we see what happens. So now it's got a whole bunch of maps. Is this going to be easier or harder? PPO did not solve this. PPO actually got like zero score on this. And again, if this takes it a bunch of steps, we're not concerned. We just want to see if it solves. What was the yellow run? Same thing as before, Captain. The environment is very sparse, so if you get lucky and you get reward at the start of training, it's a lot easier. These are the same run. But the main thing is I've never seen PPO solve this. Thought you got some solves before. The ones on single maps, it doesn't solve. Plain PPO. There's a curriculum thing that does solve, but this doesn't include that. This is just straight up prioritized experience replay. Yeah. Now, whether it solves the randomized maps, this might be harder, because on the randomized maps, there's not really a way for it to learn a robust exploration strategy when it can't just memorize some maps. The mazes are just too big. This is now 8,000 maps. So intriguingly, like, This keeps getting some score. I see PPO often just drop to straight up 0. PPO will just collapse. So this keeps getting a small amount of score. But it doesn't seem like it's able to do very much with that, which I think this makes sense. This result makes sense. It would be really cool if this just solved, but yeah, I think there are too many maps. Why do you think it got 1 to me? That's just luck. That's literally just like Brownian motion in a big maze. You don't get samples back until you finish a maze or whatever. So if you're going to get lucky, you actually have a decent chance for it to be right at the start. That's just a property of the logging. Is it worth just like increasing map size, or not a map size, model size or something here? Maybe we just do the curriculum version, or not the, I guess domain randomized version, not curriculum version. Oh, this is 25 by 25 maps. Okay, this is still not the craziest result. Let's try this. I don't want to spend very long doing this. I think I just want to run this and one other, and then we'll go back to deving on it, and I'm at least satisfied it does something. Turns very slowly. And give it 100 mil, and then we'll try the other one, and then we'll be done with this, and we will continue cleaning up code and all of that for a little bit. So this will be prior replay versus random. This doesn't seem to be performing crazy well, though. Yeah, if random immediately beats this, we're going to have to go tune some stuff. So we'll see how this does by comparison. Is this going to just do way better? Yeah, so this is just going to immediately do better. Well, this is a good thing to wonder, like, why, right? This is not going to get 100% solve. It should level off. Oh, but then the question is, why is prioritize not better here? I saw it be better on the single task. Value is the only thing that changes, right? Because when you compute the advantage, values, rewards, duns, gamma, lambda. Yeah, so the only thing that changes is the value. And you do recompute the value every mini batch. And you do recompute GAE every mini batch. Okay, so this is the curve that we have. Let's see mean samples. Mean sample uses should be 2, right? Max uses. Get out of here, bot. Alright. So it's not crazy different, really. It's not really prioritizing, is it? Well, that's weird. It should definitely be... We would expect this to be way higher. I wonder if there is something screwy here where, like, it's probably way easier to train the value function than the policy. Does that make sense? Like, if the value function learns the correct value, actually, wait, if you have a perfect value function in PPO, what happens? You don't learn anything, right? I think this, hang on, maybe what's the value loss? Value loss is still higher, but we are selecting for the highest value loss things. It's not dipping though. Interesting. Advantages.sum is 0. Okay. We have advantages. This is all zeros. Why are any of these things? Oh, right, because it's gonna be, yeah, there's gonna be some noise. Okay. Hmm. So this isn't good, right? This one just happens to be bigger. Yeah, you can't even tell what has the advantages about this. Is there like an off by one or something? Why is this it's like there's an off by one. Very screwy. What if I do this? That doesn't seem like it'll be good either, though. That'll just give you all the easy segments. I will let this run, but I'm gonna undo this. Why is advantage not giving you advantage? Delta. Rewards minus values. I see. Well, whatever I did here just doesn't work. Do we have to just like give it a couple epochs? Maybe we just give it a couple epochs and then see what it looks like. Okay, so should have had some time to learn some stuff, right? Maybe the advantages, hang on, do these line up? Did I put the breakpoint in the wrong spot? Maybe we need to do it here before I do this assign. Just make sure I'm not screwing this up. Okay. Your advantages. Well, I like the advantages at the end there. You have a positive advantage. So if we do A lot of these have rewards, right? Yeah, a lot of these have rewards. Whereas it's way sparser overall. So here you actually do get a lot of these higher reward samples into the prioritized buffer. So why is this not just immediately a free win then? Value functions trained to predict discounted returns. Oh, maybe this is the staleness. Hang on. Is it because the value function isn't action conditioned? I might have missed something here. I'm gonna have to think about this a little bit. So basically, I'm trying to see if there is actually an on-policy thing. The value function is being trained to predict either this or this. If we use this simple case, it's going to be trained to predict the rewards going forward, but those rewards are a function of the current policy implicitly. I see. Okay, but like we have stuff to play around with this for sure. We have options here because even if this is going to take more changes before we can use prioritized replay, we're still going to be able to use this as advantage filtering. All right, I've got to do a few things. I've got to get some exercise. I got to get some food. And then the goal is going to be back around 11-ish Eastern, and get in like a full day stream from there. So for folks watching, I'm going to be working on this algorithm and this implementation a lot more later. If you're interested in following all this RL dev live, puffer.ai, start the GitHub to help us out. Really helps out a lot. We're trying to hit 2K stars. If you want to get involved in dev, just join the Discord, and you can follow me on X for more RL content. Thanks, and I'll be back.